Next concept which we are studying is buffer solution. So what is meant by buffer solution? To this solution, if we add a few drops of strong acid or a strong base. Okay. So I can say some few drops. Or you can say 5 ml to 10 ml. Very small amount of strong acid or strong base. Even if you add it to this solution, then its pH value should not change. Okay. Then such type of solution we can call it as a buffer solution. Are you able to understand? See, to any solution, if I add a strong acid, what should happen to its pH value? To any solution, if I add some strong acid, what happens to its pH value? Increases or decreases? Decreases. Because lesser the pH value, greater will be the acidity of the solution. Okay. Similarly, if I add a strong base, what will happen? pH value should increase. Are you able to understand? But I am taking such a solution such that when you add small quantities of strong acid or strong base, its pH value should not change. Such type of solution we can call it as a buffer solution. Are you able to understand? So, how can we make a buffer solution? Let us see. Making of buffer. Okay. So, buffer solution can be made in one condition. First of all, you take a weak acid plus its conjugate ion salt. Okay. So if you take this solution, aqueous solution, then it behaves like a buffer. Okay. So what are the components I have to take? I have to take weak acid and its conjugate ion salt ion. Okay. Example of weak acid, I can take CH3COOH known, okay, and its conjugate ion salt will be CH3COON, sodium acetate. Are you able to understand? So this one I can call it as conjugate ion salt. How can you say it is conjugate ion salt?
Difference of 1 proton.
So there is a difference of 1 H plus. No? Are you able to understand? So in CH3COONA, what are the components we have? We have CH3COO minus plus Na plus. These are the components which we have now. Okay. Now if you see this CH3COO minus and CH3COOH, then what is the difference between these two? There is a difference of 1 hydrogen ion. Are you able to understand now? So therefore this becomes definitely conjugate ion. And to that conjugate ion, if I add Na plus, then it will become a salt. Are you able to understand? Because Na plus is formed of what? Na plus is the component of NaOH, which was a strong acid. Are you able to understand? So CH3COO minus and Na plus, when they combine together, then a salt will be formed. And what kind of salt it is? It is the salt which is made up of conjugate ion of weak acid. Are you able to understand? So therefore CH3COOH and CH3COONA, when they are present in one aqueous solution, then this solution behaves like a buffer. Are you able to understand? This is one condition. Second condition is, you can take a weak base and its conjugate ion salt. Are you able to understand? We can take a weak base also and its conjugate ion salt also. Example. So weak base NH4OH is one weak base. Already yesterday in the last class we have studied the list of strong acids and strong bases. So beyond them, every acid is a weak acid, every base is a weak base. Already we have written a list now. Only you have to check in that list whether the acids are stronger or whether they are weaker. Now if you see NH4OH, definitely it is a weak base. Now what can be its conjugate ion salt? So can I write NH4Cl? NH4Cl is a salt only. Okay. Because NH4Cl is made up of what? It is made up of NH4 plus and Cl minus. Okay. What is NH4 plus? It is the conjugate ion of what? This base. Are you able to understand? Because what is the difference between these two? One OH minus ion. One hydronium ion is hydroxide ion is difference from. So definitely NH4 plus it becomes the conjugate ion of this base. Okay. Now from where can I get this Cl minus? Cl minus is a component of HCl, which was a strong acid. So when these two combine together, then definitely a salt will be. And what kind of salt it is? It is conjugate ion salt. The salt which is made up of the conjugate ion of the weak base which we have taken. Are you able to understand? So strong acid, its conjugate ion salt. Weak base, let's its conjugate ion salt. So this will make a buffer solution. And one more condition is that weak acid plus weak base also will make a buffer solution. Are you able to understand? So whenever a question is given, you have to identify what is the given condition out of these three conditions. Okay? Conjugate buffer with the question is it is made up of which kind of solution? Is it a weak acid or conjugate ion, or a weak base, conjugate ion, or weak acid or weak base? First, this testing you have to. Are you able to understand? Right. So buffer solution is made up of these three types of. Okay. Now see this weak acid and weak conjugate ion salt. This combination I can call it as a acidic buffer. What can I call this one? Acidic buffer, because it is made up of acid only. So therefore it is called as acidic buffer. Then this buffer, what can I call it? This I can call it as a basic buffer, because it is made up of bases. So this is basic buffer. Okay. So therefore buffers are divided into how many types? Buffer is divided into two types. Buffer solution, you can divide this one into acidic buffer, and also you can divide this one into basic buffer. Are you able to understand? So this is an example of an acidic buffer, and that is the example of a basic buffer. Okay. So now we will discuss about this buffer remains to be buffer in which range.
Sir, third one for a buffer.
And this is also a buffer. But we don't have any specific name for that. So we divide buffers only into two types, an acidic buffer and basic buffer. So this one you can call it as acidic buffer in which condition? If pH value of this one is comparably smaller when compared to pH value of weak base, then you can call it as an acidic buffer. So if acid is stronger, you can call it as an acidic buffer. If a base is stronger, you can call it as a basic buffer. That's all. Okay. So next concept which we study is range of buffer. Okay. Range of buffer. What is meant by range of buffer? It is that range up to which buffer behaves like a buffer. After that it will not behave like a buffer. Are you able to understand? So, ఎంతవరకు ఇది బఫర్ లాగా బిహేవ్ చేస్తుంది ఆ రేంజ్ ని we call it as range of the buffer. Okay? For example, Vivek can bear 20 kgs of weight, 20 kgs of mass, let us suppose. తల మీద 100 kg పెట్టాం అనుకోండి, భూమిలోకి 2 ఇంచులు పోతాడు. అర్థమవుతుంది కదా? So, what is the range up to which solution can behave like a buffer? That range we are writing. So, first range is, we can write pKa minus 1 to pKa plus 1. This is one range. Are you able to understand? So, pKa minus 1 to pKa plus 1. Or if you take it in acid, you can call it as pKb minus 1 to pKb plus 1. Up to this range, buffer behaves like a buffer. Or you can call it as the concentration of salt, okay, divided by concentration of acid. Range of this one should be 1 by 10 to 10. Okay. So until this range also, this buffer remains to be a buffer. Are you able to understand? If it is less than 1 by 10, it doesn't behave like a buffer. Similarly, if it is greater than 10, it doesn't behave like a Buffer. Buffer is a combination of two things, Nama. One is salt is also present, conjugate ion salt is present, and acid also may be present, base also may be present. Are you able to understand? Similarly, same you can write in the case of bases also. For acidic basic buffer, how can you write? pKb minus 1 to pKb plus 1. Okay. Similarly for basic buffer, so concentration of salt divided by concentration of base. This should be how much? This should be 1 by 10 to 10. Okay. So in this range only, buffer remains to be a buffer. Are you able to understand? To any solution, only you can add up to very few ml of strong acid or strong base now. Okay. So pH మారడం లేదు కదా అని చెప్పి ఒక లీటర్ యాసిడ్ వేసి ఇంకా ఇది బఫర్ లాగానే ఉండాలంటే కుదరదు. Only up to small changes only it can maintain its pH to be constant. Okay. So example is human blood. Human blood is a very good example of a buffer. Okay. Human blood. So what is the pH of human blood? Do you know? pH of human blood is approximately 7.35. Okay. So we eat many kinds of foods. Are you able to understand? ఒక టమాటా తిన్నారనుకోండి, దాంట్లో సిట్రిక్ యాసిడ్ ఉంటుంది. Immediately what happens to the pH of your blood? pH should reduce, no? Are you able to understand? No? If you are eating any acidic fruit like a citrus fruit or tomato, immediately your pH of the blood should reduce. But the pH of the blood never reduces. It remains to be 7.35. Are you able to understand? It means the blood is behaving like a buffer solution. So in many acidic reactions also, we need pH to be maintained constant. Are you able to understand? So human blood is a very good example. Like that. Okay. So then what is the method of finding pH of this buffer? Let us. Okay. So pH of buffer can be written as pKa plus half log concentration of salt divided by concentration of acid. So this is the formula of finding pH of this buffer. Are you able to understand? Similarly, if you want to calculate for base, you have to write POH is equals to pKb plus half log of salt divided by concentration of acid. This is the method which you have to adopt. Are you able to understand? Base. Okay. These are the values which you are supposed to remember. So after this, we study about buffer action, which is important to understand now, because one time person was directly given on action of buffer. Okay. So this concept we can call it as buffer action. Okay. So for example, let us take acidic buffer. Okay, we will take acidic buffer and we try to understand how this pH of this base remains constant. What is meant by buffer action? Buffer action means what? How this buffer is able to maintain its pH. That is called as buffer action. Okay. So if you want to make a note of this, how buffer maintains pH. So what is the logic behind the maintenance of pH of this buffer? Okay. Let us take an acidic buffer. Let us take CH3COOH and let us take a CH3COONA solution, aqueous solution. Okay. Aqueous solution. Then in this aqueous solution of acetic acid and sodium acetate, can you say what are the different ions which are present? Spelling correct. Tappa. Aithe indire. Okay, CH3COOH and COONA aqueous solution if you take, Then can you say what are the different ions which can be present in this solution? If you take aqueous solutions, they split into different respective ions. So what are the different ions which are present? So CH3COO minus will be present. H plus will be present. That's all. And here also CH3COO minus may be present and Na plus may be present. Okay. So in addition to them, there is one more component. Can you say what is that? Huh? H2O అంటేనే aqueous solution. ఇంకా వేరేది ఏదైనా చెప్పండి. OH మైనస్ ఎక్కడ నుంచి వస్తుంది ఇక్కడ OH మైనస్?
వాటర్ స్ప్లిట్
వాటర్ స్ప్లిట్ అయితే ఓకే. సో బికాస్ ఆఫ్ స్ప్లిట్టింగ్ ఆఫ్ వాటర్ we can write H plus and OH minus. Still there is one component in this aqueous solution. What is that? దీనిపైన ఒక క్వశ్చన్ కూడా చేస్తాం. Hydronium ions are nothing but H plus only when they react with water. There is one more component. What is that? One more component is CH3COOH itself. See, CH3COOH, it is a very weak acid. No? What is meant by weak acid? It doesn't dissociate very much. So dissociation is very weak. No? So only very few molecules of CH3COOH they split into CH3COO minus and H plus. So most of the molecules of CH3COOH they doesn't dissociate. Person would just already able to understand. So these are the different components which are present in this acidic buffer. Okay. Now what I will do, I have to check how this pH doesn't change when I add some strong acid or strong base. So let us see. Here now. So let us take let us add few drops of HCl. Okay, I am adding few drops of HCl to this acidic buffer, and this is an aqueous solution. Immediately, what happens to this HCl? It splits into H plus and Cl minus. This is what happens to. So when it splits into H plus and Cl minus, what happens to the H plus ion concentration? What happens to the H plus ion concentration? Already there are some H plus ions. No? Now there are some additional H plus ions. So what happens to H plus ion concentration? Increases. So what happens to the basic nature of the solution? Acidic nature of the solution increases. If acidic nature increases, what happens to the pH? pH value should decrease. But buffer must maintain its pH. Are you able to understand what is happening? So therefore, these H plus ions, they react with what? See anything which they react with? They may react with OH minus ions. Are you able to understand? So this H plus, it may react with OH minus ions. Are you able to understand? Or is there any other method of? Okay. So this H plus, it may also react with CH3COO minus. Are you able to understand? So this H plus, which was released by addition of strong acid. So this H plus, it may react with OH minus also. It may react with CH3COO minus also. Are you able to understand? So then what is formed again? Again CH3COOH will be formed. Okay. So for example, if 10 H plus ions are released, 10 H plus they react with 10 molecules of CH3COO minus. Are you able to understand? So what is happening to the H plus ion concentration? H plus ion concentration is not increasing. No? So therefore pH of the solution also does not increase. Are you able to understand? Okay. So what is pH? Already we have studied. No? pH is negative logarithm of H plus ion concentration of the solution. This is called pH. No? Basic concept. pH means what? Negative logarithm of H plus ion concentration of the solution is nothing but pH. Okay. So as H plus ions they are released, they are reacting with CH3COO minus and acetic acid is formed. So pH concentration is not increasing. If pH concentration doesn't increase, definitely this solution behaves like a buffer. Are you able to understand? Similarly, let us take one more example. Clear? if I add strong base, let us see what happens. Okay. So addition of strong base. Okay. Let us take which example shall I take? I will take sodium hydroxide. Are you able to understand? So this NaOH, if it is put in aqueous solution, immediately it splits into what one? Na plus and OH minus. Clear? So OH minus ion concentration is increasing. If OH minus ion concentration increases, what happens to the basic nature of the solution? Basic nature increases. But basic nature should not increase. So what happens? Can you say what happens? A possibility ఉంది చెప్పండి. Immediately when you add NaOH, it splits into Na plus and OH minus. So the number of OH minus ions they are increasing. So basic nature increases. But I don't want the basic nature to increase. So what can be the possible reaction?
OH minus H plus to molecule.
That is the only possibility. See, OH minus ions, they react with H plus ions. Are you able to understand? So let us see. So OH minus ions, they react with H plus to form water. Are you able to understand? So therefore, the concentration of OH minus ions is not increasing. The concentration of OH minus ions is not increasing. Why it is not increasing? As soon as NaOH is added, OH minus they react with H plus, and the concentration of OH minus is remaining same. OH minus ion concentration lo marpu ledhu kada. So therefore basic nature does not increase. But the problem is that H plus ion concentration has reduced. That is one problem. Okay. So OH minus ion concentration is remaining same. But it is reacting with what? It is reacting with H plus. So what happens to the H plus ion concentration of the solution? H plus is reducing. So as soon as H plus reduces, CH3COOH, again it gets dissociated into CH3COO minus and H plus. This is what happens. Okay. For example, if 2H plus they are disappearing, immediately 2 molecules of CH3COO minus, again they will dissociate to give 2H plus ions. Okay. So OH minus ion concentration is not reducing. H plus ion concentration is also not reducing. So again pH of the solution remains to be same. So this is how the buffer is able to maintain its pH. Is it clear now? So therefore, what is the final conclusion here we have to see is SEMA. Question was asked on this conclusion only. I think in 2012 or sometime, SEMA. So H plus reacts with OH minus to form water, which is an unionized molecule. Clear? Similarly, H plus it reacts with CH3COO minus to form CH3COOH. And what is this CH3COOH? It is unionized molecule. Okay. Similarly, here also what is happening? OH minus reacts with H plus to form H2O. So what is this H2O? This is also called unionized molecule. Clear? Similarly, CH3, this is a different condition. Are you able to understand? So therefore, in the action of a buffer, how buffer is able to maintain its pH? By forming the unionized molecules. This is the answer. Are you able to understand now? So make a note of that. So what is the final conclusion we have to draw now? So buffer is able to maintain its pH. Because as soon as strong acids or strong bases are added, as soon as strong acid or strong base is added, it forms what much? Unionized unionized molecules. Okay. So therefore it is able to maintain its pH. That is the case. So understood now what is meant by buffer here? Okay. So buffer means what? If H plus are additional, H plus react with something so that unionized molecule is formed. So if OH minus, if they are added, immediately OH minus reacts with H plus to form unionized molecule. So therefore it is able to maintain its pH. But already the range of buffer we have written now. It can maintain its pH only up to certain level. After that it doesn't behave like a buffer. Clear? Right. So this is the question now. So buffer solutions have constant acidity and alkalinity. Alkalinity means basic nature, because we have to select one of these four options. Clear? So they give ionized acid or base on reaction with added acid or base. Acids and alkalines in the solution are shielded from attack by other ions. They have large excess of H plus and OH minus ions. They have fixed value of pH. What can be the answer? Huh? This is the first answer. Okay, no? So they give what they give? Unionized molecule. The molecules which doesn't behave like ions. Are you able to understand? Unionized acid or base is formed when acid or base is added. Okay. So they are shielded from attack by other ions is not correct. They have large excess value of H plus and OH minus. This is also not correct, because they definitely have some H plus and OH, but excess quantity is not present. Are you able to understand? So this is also wrong. And they have fixed values of pH. They are fixing this pH only because of this reason. So this will be my correct answer, and remaining I can consider them to be wrong. That is the answer. So let us see what is the data which is given. In a buffer solution, concentration of NH3 is given. So it means NH3 is an acid or a base, no? NH3 acid or base, NH3 is a base. Clear, no? So concentration is 0.30 molar, and concentration of NH4 plus. What is NH4 plus? NH4 plus, definitely it is a conjugate ion of that particular base. Are you able to understand? So it is 0.20 molar. So if Kb of NH3 is 1.8 into 10 power minus 5, find the pH of the solution. Are you able to understand? So therefore, pOH is equals to pKb plus logarithm of concentration of salt divided by concentration of base. This is the concept now. Okay. So therefore, pKb, how can I write? pKb can be written as negative logarithm of Kb. This is how I can write now. So pH can be written as negative logarithm of H plus concentration. pOH, how can I write? Negative logarithm of OH minus ion concentration. So therefore pKb can be written as negative logarithm of Kb. Are you able to understand? So therefore pKb is equals to negative logarithm of, what is the value of Kb, which is given 1.8 into 10 power minus 1. Okay. So if any value, if it is given in negative log of minus 1.x into 10 power y, this is the format which we have written previously. So this value is in which format? This is in the format of x into 10 power minus y. Then how can I write its value? I have to write. So 5 minus log 1.8. This formula already we have studied now. If it is of the form of x into 10 power minus y, then this value can be written like this. 5 minus log 1.8. Okay? Or you can write y minus log x. This is how you have to write. Okay? So therefore, now do the calculation. So therefore, pOH is equals to pKb. pKb value is how much? So it is 5 minus log 1.8 plus log of concentration of salt is how much? Concentration of salt is 0.22. Concentration of base is how much? 0.0. That's all. So therefore, POH, how I can write it is a 5 plus, can I write it as log 0.2 divided by 0.3 multiplied by 1.8. Okay. Here I have minus log, here I have plus log. Are you able to understand? How can you write in single logarithm? Log A minus log B? Log A by B. So by using that method we are writing. Are you able to understand? So log 2 by 3 divided by log 1.8. So log of 0.2 by 0.3 into 1.8. I can write like this also. So therefore, POH, how can I write? It is equals to 5 plus log. So 2 by 3. 8 in 3 is it? 0 point, or I can do one thing. I can write 1 by 3 into 0.9. I can write like this. So 2 9s are 18. So I can write like this. So therefore, 1 by 3 into 0.9 is 2.7. So POH of the solution is how much? 5 plus log n. So 1 by how much? 2.7. That's all. So
0.9 minus.
but here we have written 3 now. 2 into 0.9 is 0.2 into 9 is 1.8. Okay. But here I have 3 now, but previously we had 0.3. So 3 into 1.9. I can write like this. Okay. So therefore, POH is how much it is? 5. Now this log of 1 by 2.7, how can I write? Log of 2.7 is given, so I will take log to the numerator. Then what I will write? I will write 5 minus log of 2.7. I can write like this. Are you able to understand? Because log 1 by x can be written as log x power minus 1. No? Minus 1 comes here, so minus log of 2.7. I can write like this. Okay. And log 2.7 value is already given. No? Log 2.7 value is how much? 0.2. So therefore POH is how much? 5 minus 0.24. But he is asking us to find a pH number. We have calculated what? POH, but he is asking us to find a pH. So how can I calculate a pH value? 14 minus pH. This is the formula. So 14 minus pOH value is how much? 5 minus 0.4. Okay. So if you do this calculation, what I will get? I will get 14 minus 5, 9 plus 0.43. So it is a 9.4. So this is nice. Have you understood? Clear? It's a very simple calculation. Make a note of it. Okay. See. So what is the H plus ion concentration in moles per liter of a solution such that concentration of acid is, this is salt number. Concentration of salt is this much and concentration of acid is 0.10 and Ka value is already given. Clear? So therefore, what is the equation to calculate pH now? pH is equal to pKa plus logarithm of concentration of salt divided by concentration of acid. This is how we have to write. Are you able to understand now? And what is meant by, he is asking H plus concentration. So what is the relation between pH and H plus? Relation between pH and H plus. pH can be written as a negative logarithm of H plus ion concentration. That is pH. ఇప్పటికి 100 సార్లు రాసినాం ఆల్రెడీ. ఇది 110వ సైడ్. 101వ సైడ్. Okay. Similarly, pKa, how can I write? pKa can be written as negative logarithm of Ka concentration. That's all. So therefore, here we have one logarithm. So listen very carefully how we can solve this one. Here already we have logarithm, and here also there is one logarithm. Here also there is one logarithm. So if you write everything in terms of logarithm, then solving becomes easy. Okay? So write down. So instead of pH, what I can write negative logarithm of H plus ion concentration of the solution. pKa, how can I write? Negative logarithm of Ka of the solution plus logarithm of salt, or in this variable, right? concentration of salt divided by concentration of acid. That's all. So I want pH only H plus concentration now. So you better remove logarithm on every side. How can I remove? So I can remove like this. So this I can write it as log of 1 by H plus ion concentration. I can write like this. So this is equals to, now this is of the form of log A minus log B, no? Log A minus log B? Log A by B. So therefore log of, so concentration of salt divided by concentration of acid multiplied by K. This is how I can write it. Is it clear? Now logarithm I can get cancelled. If I can cancel, then what I have 1 by H plus ion concentration is equals to concentration of salt divided by concentration of acid multiplied by Ka value. Okay. All the values are already given. Just substitute in the equation. That is my required answer. So I have calculated 1 by H plus. Now I want H plus. If I want H plus, what I have to do? So take the reciprocal of all of them. Okay. So therefore, H plus ion concentration is nothing but concentration of acid multiplied by concentration of Ka value divided by concentration of salt. So, what is the concentration of acid given now? 0.1. Ka value? Ka value? 1.8 into 10 power minus 5 divided by salt? 0.2. That's all. So therefore 1 by 2. So therefore 9. 0.9 into 10 power minus 5. This is my answer. Okay. Understood? In option 0.9 is it given? 9 is given. No? So how can you convert this one into 9? So 9 into 10 power minus 6. That is the H plus concentration of the solution. Is it clear? That's it. Okay. So see this question, in a buffer solution containing equal concentration of B minus and HB. Okay. So this is some general acid which is given. Okay. So the Kb for B is 10 power minus 10. Then what is the pH of the buffer solution? Able to understand? So therefore he is asking pH number, but here Kb value is here. So generally you may get confused here. Are you able to understand? pH he is asking, but Kb is here. Kb means it is the dissociation constant of a base. But I want for acid now. So how can I calculate Ka value? So already we studied that Ka multiplied by Kb is equals to Kw. Do you remember? Okay. And it is equals to 10 power minus 4. This relation already we have now. So class of the Anna we have. Okay. So therefore Ka value. So Ka value is how much? 10 power minus 14 divided by Kb. That's it now. So 10 power minus 14 divided by Kb value is how much? 10 power minus 10. So it is a 10 power minus 4. So that is the required Ka value. Understood? Now substitute in the equation. So pH is how much? pH is pKa plus logarithm of concentration of salt divided by concentration of acid. So he gave that concentrations are equal, no? Equal concentration. Equal concentration of this acid and its conjugate base. Are you able to understand? So therefore, log of salt divided by acid will become how much? It will become 1. So log 1 to the base 10. Log 1 to the base 10 will become 0. So therefore, pH value is pKa plus log of 1 to the base 10. So log 1 to the base 10 is 0. So pH is equals to pKa plus 0. Okay. So what is pKa value? It is 10 power minus 4. So therefore pH value is how much? pH value is 4. That is our answer. Are you able to understand? Okay. Okay. See. So this is the question. Which of the following pairs constitute a buffer solution? In which of the following buffer solution is present? So what is meant by buffer? Already we have studied now. It is a combination of weak acid or weak base with its conjugate ionic salt. Clear? So if you see NaOH, it is a strong base. So this cannot be my answer. Clear? HNO3 nitric acid is a strong base. This also strong acid. Clear? So this also cannot be my answer. HCl is a strong acid. So this also cannot be my answer. So buffer solution should be made up of weak acid and its conjugate salt. Understood? HNO2 is a weak acid and its conjugate salt is Na. So this is my answer. Clear? That's it.